Welcome back, everybody. What day is this, Lauren? I know you're tracking the dates for me. Sound undecisive.
I don't know.
All right, let's take a look.
I believe it's
Is it on campus? Does it say lecture day 4?
in my notes, the last note that I had said lecture day 4.
Okay, we'll just go with lecture day 5. We'll assume that James, as we was talking about, and Lauren's indecisiveness is correct. All right, so lecture day 5. Last time we were working on radical expressions. And I wanted to do some more with it, some more practice with it, because we're gonna hit the main topic today in class. We're gonna spend a full 2 hours on it in the main class. There's a lot of shit going on in this one. As a quick reminder, if we have the nth root of x to the m, this equals x to the m over n. And you can separate that 2 ways. You can say x to the 1 over n times m, or x to the m times 1 over n. And we do that, we make that multiplication, we can put these in parentheses. And this becomes the nth root of x to the mth power. And this actually takes us back to that. That's a quick reminder of how the radicals switch to fractional exponents. If we have a cube root of x to the 8th power. Anyone remember how to do that? We did this last week. But it's been a good 5 days.
X to the 8 over 3.
So we got x to the 8 over 3. How does that simplify?
2 x's in the radical and
Why?
because it's not divisible by the 3.
So we divide 3 and 8, you're onto something here. If we divide 3 into 8, we get 2. And so this is a 6 and there's 2 left. So we got a remainder 2. This is the same thing as x to the 2 2/3. Which is the same thing as x squared times x to the 2/3. Because 2 2/3, despite writing like that, it really means 2 plus 2/3. So that can split into this, and this goes back into the radical. And we still have 2 x's in there, x squared, as you were saying. I think that's what you were going for. But we were able to pull out an x squared. Which makes me think I shouldn't have used something that had 2's on both spots. So let's do another one where it's just slightly different. We'll do the 4th root of x to the 9th. Try doing that one by hand. Give that a gander. Do it together in like a minute or 2. Alright. So someone walk me through this. What am I doing here?
The same. Same thing. Um. I know the way that I probably explain it is not the right way, but, the answer pretty much is, two x squared. And then 4 radical sign and x, right?
So this is what I heard you say. Which is,
Two.
Not the two.
Yeah,
right, not the two, right? So x squared is how we say that, and then 4 radical x squares. This was x to the 9/4. So if we do that division, 4 into 9 goes in twice with a remainder of 1. So it's x to the 2 1/4. Because the radical goes on top of the fraction. And that splits into x squared times x to the 1/4. And I'll give us that. All right. Any questions? Okay. You're the one that got the answer right.
Oh,
You're fucking with me. What's up?
do we have to do the second half, like, or would you,
This is where you should get.
oh, okay, so
All of this was me slowly writing it out for lecture purposes. This is the slow, detailed method. Alright. Then we looked at multiplying radicals. So we have 4th root of x cubed times the 4th root of x to the 8th. This becomes the 4th root of x cubed times x to the 8th. They go together. And that was me doing the slow way of showing that. And then simplified form always has as exponents inside less than the index of the radical. Which means we need to simplify this. 4 root x to the 11th is x to the 11/4, which is x to the 2 3/4. So x squared 4 root 3. Which, if we come here and look at it here, we could have done that right away. This right here is x squared when you simplify it. And this one's already simplified, so we just put the two together. And we get that.
Would it be x squared 4 root 3 or x squared 4
Oh.
root x to the 3?
You know, it's not that, it's this. That's me fucking up. Seeing if you're paying attention. Yeah, that's it.
Yeah, I got it.
That's the ticket. Alright, so I don't think we did the next part on Friday. That was a quick, like, get your head into the radical zone. I like that, the radical zone. That sounds fucking cool. Sounds totally radical. So let's say we got square root of 2 plus square root of 5 over square root of 3 minus square root of 4. This is something we'll be doing in more detail today. Simplified form also means No radicals on bottom. And the minus sign means we can't just divide the shit up into it.
It's square. Side and then bring that up. And
Oh, can't square for no reason. Cause that would change the value. Like if I had 2 and I just squared it, I have 4. I wish I could do that to my bank account. That'd be fucking, cause I just got paid. That would be glorious on the bank, right after payday, when your account is flush. So what we do is we take the bottom and change the sign to a plus. And to make it so we're not changing the value, we want to treat this like we're multiplying by 1. Multiplying by 1 doesn't change the value. And so to make this multiplying by 1, we're going to put the same thing on top. Because that will simplify to 1, and we're not changing that. So I got square root of 2 plus square root of 5, just rewriting it so I got a little room to work. On the top, we can multiply it out. Square root of 2 times square root of 3 is square root of 6. Square root of 2 times square root of 4 is square root of 8. Square root of 4 is not a good fucking number. I shouldn't have done that. Oh well, fuck it. That's what we're using. Square root of 4 is just 2. That's okay. Square root of 5 plus or times square root of 3 is square root of 15. And square root of 5 times square root of 4 is square root of 20. On the bottom, I have square root of 3 squared plus square root of 12 and minus square root of 12. And then minus square root of 4 squared. Okay, so the bottom, this is 3, those cancel. And this is minus 4. So 3 minus 4 on bottom is -1. On top, and I should have done this when I had the 4 square root of 4 here. That is square root of 4 times square root of 2, which is 2 times the square root of 2. And that one is square root of 4 times square root of 5, which is square root or 2 times the square root of 5. None of these add together, so we got square root of 6 plus square root of 15 plus 2 square root of 2 plus 2 square root of 5. And since the bottom is a 1, we don't need it, we'll just move the negative up and make everything negative on top. Alright. Questions? Now, I could have done square root of 2 or made this a 2 up here. And done the multiplication and would have saved us a step here. But sometimes it's not as obvious. And so you always want to try to clean them up at the end. I'll give you another one where it's not as obvious, but we might have something going on. Notice we didn't have any radicals left on bottom. So we had. All we did is change the sign. So if you've got A and B and then A and minus B. Well, first off, we had the formula A squared minus B squared. Which is what that ended up being. This was A squared minus B
Yeah,
squared.
that's what I mean.
But also, these two things are called conjugates. We're gonna use that phrase again a little bit. Conjugates just means one, you switch the sign of one of them. And when you multiply them together, they clean up the ugly shit. They're like a good coat of paint. Alright, so let's come up with one that I can give you guys to stumble your way through on. Okay.
think. It was kind of still. Last part.
Put it together in a bit. Everybody else is still working, I wanna give them a chance to. Figure it out if they can. And I would recommend when you're doing this at home, if you can, practice without using a calculator. Because all of this, I'm gonna do it without a calculator, and I'm not gonna do any of the multiplication. If anyone did 15 times 21, I'm sorry for you. I'm not even gonna bother. 15 times 14, I'm not gonna do. Well, I might have to do 15 times 14, then I don't have anything coming. But the more you practice at doing like the basic math, the better you get at doing it, and pretty soon you don't need to write it out, you just start doing it in your head. And if you're going through this class, there's a good chance you want to be doing like engineering or something like that. And do you ever see engineers pulling out a fucking calculator? No, they don't. Make sure everyone start off the right way. Maybe I should do that. Hopefully you all multiplied by square root of 15 plus square root of 21 on top and bottom. Some books are still going, so I'm gonna stop. That was just to make sure everyone started correctly. The easy part should be the bottom. If you're not taking advantage of that difference of squares, you made this really fucking hard. The bottom is square root of 15 squared minus square root of 21 squared. 15 minus 21 is -6. So the bottom is going to clean up to -6. So I'm going to do the next spot here just because I need to write big. I'm going to have square root of 6 times 15. I'm not going to multiply that out. Then I'm going to have square root of 6 times 21 plus square root of 14 times 15 plus square root of 14 times 21. All that's over -6. All right, so this is 6 is 2 times 3, and 15 is 3 times 5. So I got this is really 3 squared times 10 in here. Plus, this is 2 times 3, and then 21 is 3 times 7. So this is a 3 squared times 14. Getting it down to the prime factors, that way I can see how to simplify it before I do the multiplication. So that gives me my 3 squared, and 2 times 5 is 10. 3 squared here, 2 times 7 is 14. Here, this is 2 times 7 and 3 times 5. That doesn't really get a lot better, but I don't need a calculator for this because I know 2 times 5 is 10. 7 times 3 is 21. And 21 times 10 is 210. So that's not going to simplify, so I'll just put 210 now. This one is 2 times 7 and 3 times 7. So I got a 7 squared in there. And then 2 times 3 is 6. All this is over -6.
So that's the final answer, right?
No, I'm gonna pull out the squared stuff. So this becomes 3 root 10 plus 3 root 14 plus square root of 210, which doesn't clean up, plus 7 root 6. All divided by -6. You can leave it that way, or if you simplify it, you want to put like the -6 each one. 3 over 6 would be -1/2. That one isn't going to clean up. And then we got -7, 6, square root of 6. But either of these last two is good.
For the square root of 14 times 15, that didn't clean up at all, that's why I put square root 210.
Yeah, it didn't clean up, so you don't want to leave it as 14 times 15, that just looks lazy. And if you want to use a calculator, where you can, but notice just doing some little manipulation with the digits. I was able to find the multiplication without doing simple multiplying. It doesn't come easy getting that way. Practicing doing it will make you quicker at it. Obviously, you don't want to like be practicing on the final, do it as quick, or the test, do it as quick as you can on the test. Or if you've got the time, multiply it out and then use the calculator, check your work, see how you did. But if you practice on the homework doing shit like this, pretty soon you stop writing down this step. You can identify what this is going to be. I need a 3 out of that and a 3 out of that. I got 2 and a 5 left. That's 10. 3 and 3 is 9. And you'll go. You can do it in your head and not need to write down. But it just comes with practice, and which is ultimately faster in the long run. You may save time in the beginning pulling out the calculator, but if you become reliant on the calculator, you're going to do the calculator for fucking everything. Was that fun? Was that everything you hoped it would be?
You
You know, Lauren. Would it be more fun if I had variables in it?
No.
I heard yes. Did you hear her say yes? I heard her say yes.
Side on the floor.
Really?
Yeah.
That hurts my feelings. Now I gotta make it worse. Alright, got it. Yeah, Lauren's face crunching up like I fucking fed her something foul.
You would. Step 1, you would multiply by. Square root of YZ minus square root of YX on both top and bottom, right?
Yes,
Okay. So whatever that sign is, you just flip it.
correct.
Okay.
Started playing Pal World this weekend. I was so against doing it, because it looks like Pokemon, and I'm like, I'm too old for that shit. But like, I had a lot of friends my age, a couple of them were playing it, and they're like, you should try it, you're really gonna like it. And I did, and I literally played all day Sunday, except for like a 3 hour break. So I put in a good 10 to 11 hours on Sundays. Playing Power. What do we have at bottom?
Is it YZ minus YX?
Yeah,
It is?
Yep.
That's cool.
this should actually have been easier than working with the numbers. Because the numbers, you wanna run the calculator, but here none of the shit fucking combine. You can't fucking multiply X and Z and get like a new letter. Well, we could, but it doesn't help us. So we just distribute and I get XY times YZ. So XY times YZ is XY squared Z. Right?
Oh, wait. Yeah, I put the Y square on the outside, is that makes it
Well, we're gonna get there. No, we're doing the outside.
like the outside of the radical, like I did Y squared and then in the radical XZ,
No, that is gonna be wrong,
that's wrong.
because we gotta take the square root of Y squared, it's only gonna end up as Y squared XZ. So that first one is gonna be Y squared XZ.
So it's not Y squared because we have to take out the square.
You gotta deal with the radical. That ends up being the square root of X times the square root of Y squared times the square root of Z. Square root of Y squared is Y.
Yeah, okay, yeah.
Okay, so we do the next one. XY times YX is what? What goes in the radical?
Y squared and X squared,
Y squared and X squared. So when we come down here, that's just a Y and an X. Or X and Y.
is there any like rule on what variable is supposed to go first or? The alphabetical,
Alphabetical is the normal thing to do, but there's no rule against doing YX. In fact, that's why I did it, just to throw a little hiccup in that shit. And then we do the XZ times M, so I got plus square root of X, oop, that goes up here. Plus square root of XY and then Z squared. Which looks like a Z comes out and we're left with XY inside. And finally, we got plus XZ and minus YX. So plus square root. Minus square root. We got X squared YZ. Which when we come down here. Gonna be minus X squared root of YZ. So. Making it look a little bit prettier. Get rid of all that sloppy writing. And putting them in alphabetical order.
Got the problem right, I think I just messed up on, subtract, I forgot to bring the, negative YZ and negative, XY up and subtract them.
Wait, what?
I think I added it interesting because I forgot to. Do
Now, there is one thing I didn't tell you. And I don't know if we talked about last week. This answer is technically close, but not correct. The square root of X squared isn't X. When we don't know the value, it could be negative or positive. We say it's the absolute value of x. This only happens with variables. Only with variables. And only with even indexes. With an even index. The reason why is if I plug in, let's say, just to show you where this is coming from. If I say x equals -2, this becomes the square root of -2 squared, which is the square root of 4, which is 2, which is the absolute value of -2, which is what we started with. So the absolute value of x. It only happens with variables and only with an even index. If it's an odd index, that problem doesn't happen because we can have negative results. For example, we looked at the cube root of x, or cube root of x cubed. We said x is -8. This is a cube root. Ah, fuck.
64 times 8.
64 times 8, we got a 480 and a 32 is 512. But we got 3 negatives, which makes it a positive or negative. And that does stay like the negative doesn't go away. So this ends up being -8, which was the original x. So when the index is odd, that problem doesn't happen. But when the index is even, like here, the invisible 2 or like 4 or 6, and we have the same exponent on the inside, we gotta do absolute value. It's gonna seem unimportant here. It actually matters when you get to calculus. All right. One more fun thing. We want to clear that radical out of the bottom. So let's say I've got, I don't know, let's just say 1 over the 5th root of x cubed. This is a little different than the easier one. If we just did 1 over square root of x, we don't want a radical on bottom. If I multiply that by square root of x over square root of x, I get square root of x over x. But if I do that here, multiply by the bottom, I don't get x. The key here is recognizing this was x to the 1/2. So we chose to multiply by something that when I added the exponents, I got a 1. Does that make sense? So what we're going to do on this one, I'm going to write that as 1 over x to the 3/5. And if I want to end up with x to the 1st on bottom, it's going to be 3/5 plus something else. What do I got to add the 3/5 to get 1? 2/5. Because that's 5/5 equals 3/5 plus question mark. So it's 2/5. So that's what we got to multiply on top and bottom. So this gets to be the 5th root of x squared over x. All right, it's 3 o'clock, so I'll stop shoving math knowledge down your brain.